Welcome back to the Complexity Science online tutorial series. This tutorial series is presented to you by AC4, the Advanced Consortium on Cooperation, Conflict and Complexity, at the Earth Institute, Columbia University. So far, we have discussed what complexity science is, the differences between complicated and complex systems, and the dynamics of complex systems. In this fourth module, we will focus on another key property of complex systems, the organization that emerges from the interaction between the system's parts over time, called self-organization. First, we will revisit the flock of birds from Module 1 and see how their amazing coordinated movement is created from following just 3 basic rules. Then we will look at the way ants search for food and see how simple rules of interaction result in an emergent self-organized system, which optimizes the complex task. We will then move to self-organization in social systems and hear from an expert regarding how these concepts apply to workplace teams. We will conclude by looking at Wikipedia and riots in urban contexts as 2 large-scale examples of emergence and self-organization in the social world. Remember the beautiful coordinated movement of the flock of starlings? Let's see how this complex phenomenon emerges from following just few basic and simple rules that govern the interaction between the individual birds. Scientists have found that individual birds in the flock follow just 3 basic rules. Separation, don't bump into your neighbor. Cohesion, stay away from the edges of the group and try to move towards the center. And finally, alignment, move in the same direction as the other individual you can see around you. When these rules are put into a computer simulation, they produce these dynamics. In this example, 2 predator birds have been added to emphasize the way the flock coordinates the movement to avoid them. Let's look at an example of how this understanding of an overall organization emerging from local interaction can help us understand other social phenomena, like the movement of human crowds that can be simulated using the same basic rules that governs the movement of the bird's flock, or the outbreak of an epidemic and its spreading through the population, which is also an example of how simple local interactions create an overall order, and also the growth and organization of cities. It can show us how emerging urban centers as well as areas of poverty are created following basic rules of local interaction. Moving back to the natural world, let's look at an ant colony. Ants are almost blind and live in huge colonies. Survival rests on a constant search for food outside the nest. Ants have developed a unique way to communicate and interact that help them optimize their foraging efforts by following the shortest path to the food source. Research has found that the ants communicate with one another through smell, using a chemical called pheromone. As foraging ant moves, a certain amount of pheromone is left on the ground marking its path. Other ants searching for food follow the trail of pheromones left on the ground, and the ant that took the shortest route to the source of food will return first to the nest, leaving the strongest pheromone path for others to follow. Over time, the pheromone in other paths evaporates and all food foraging movement converge to the shortest path. What is displayed here is a computer simulation of this phenomena. Using this computer modeling, scientists were able to confirm that simple foraging rules do indeed explain the emergent ant's behavior. So ants work hard and manage to coordinate their team efforts. Can searching for emerging self-organization help us understand the human workplace too? Let's hear from Dr. Beth Fisher-Yoshida of Columbia University, who will describe the way of these dynamics play out in the workplace environment.
When we work in teams, either a sports team or in an organization, each of us brings our own patterns of behavior with us, our own patterns of communication. And then as we interact in the team, a certain kind of a pattern emerges from that team dynamic, which is different from the combination of the individual contributions. All it takes is one member of a team to change, and the whole system, the whole pattern from the team changes to a new emergent system.
Thank you, Beth, for this example. In a similar way to how teamwork emerges out of the interaction between individuals over time, local interactions between people can result in the emergence of larger patterns of interactions within our social world. One example is the emergence of large-scale riots in the city centers. Looking back at the London riots of 2011, researchers mapping the locations of all London riots found that they tended to emerge within a short walking distance from both a commercial city center and a large housing estate. Researchers also found that generally the spreading of riots in the city closely resembled the pattern of wildfire growth, including the fact that they usually die out, but few can become catastrophic. Like wildfires, riots, once they reach a certain magnitude, can become self-sustaining and can be very hard to contain and diffuse. A more peaceful example is the collaborative online efforts to share and organize human knowledge through the online site Wikipedia. Starting as an initiative that was intended to contribute knowledge online through a centrally edited process, much like traditional encyclopedias, its founders soon realized that by opening the editing process of content to every interacting user, and by developing simple rules that govern how content is edited and changed, they managed to both enlarge the number of entries written and to improve their quality, far beyond what they achieved through the centralized control process. Establishing basic rules such as allowing anyone to edit the content and requiring a neutral point of view, they managed to create a collaborative platform that allowed for the emergence of one of the most diverse and extensive self-organized volumes of shared knowledge that has ever existed. Today, Wikipedia offers more than 24 million articles, written in over 280 languages. Recapitularly learning from this module, we can say that the emerging self-organization of a complex system, often based on an interaction between parts that are following a set of relatively simple rules. This basic set of rules can sometimes be transferable from one context to another, such that scientists are able to apply learning from one system to another. Principles of emergence and self-organization can be applied across a wide range of social phenomena, from the workplace to large-scale complex social dynamics. These are the sources that have been used to make this module. In the following modules of this series, we will explore more of the unique attributes of complex systems, such as nonlinear causality, unintended consequences, and the dynamics of interaction between elements of the system, such as feedback loops and attractors. Thank you for watching.